We are going to look at graphing tangent and cotangent. We will use patterns. If you have not watched my graphing sine and cosine video, you might want to do that first, as the pattern thing will continue. First, to remember, tangent is sine over cosine, right? It's a quotient. Cotangent we can think of as in two ways. First would be cosine over sine, so the quotient, or you can look at it as 1 over the tangent. Okay, either way. Let's look at what these look like. Tangent. Tangent is sine over cosine. Let's think about that for just a second. If I were graphing sine on this graph, it would start at 0. And if I were graphing cosine, it would start at 1. So sine over cosine is giving me 0 over 1, which is 0. Okay. Tangent starts at 0 because of what we just went through, the sine over cosine. What's really important to note is that tangent does not have an amplitude because there's no wave, right? And the definition of amplitude is half the height of a wave. But we're still going to use that number. I call it the fake amplitude just for our intents and purposes, okay? The other thing that's really important to know is that the period for tangent is pi, not 2 pi. Let's look at tangent again. Tangent starts at 0. We could talk about why, but we end up with asymptotes on either side of that 0, each half of the period away from the 0. Then our fake amplitude is going to tell us what happens next. Halfway between our asymptote and our 0, we're going to go down. That whatever that amount is, in this case it's 1 because that's the coefficient of tangent. On the right-hand side, we'll go up. My tangent graph looks like that. When I remind myself what tangent looks like, I tell myself it starts at 0, or 0 at 0, and it looks like that, kind of like a cubic. For cotangent, cotangent has an asymptote at 0, another asymptote at the end of its period, halfway between is a 0, and then cotangent leans the other direction, so it goes up to down. This would be my cotangent graph. Again, I don't know that I specified it enough on the last one, but notice that this is the period, which is pi. So we want half of the period to the right of the 0 and half the period to the left of the 0. We did the same thing here with tangent. Half of the period to the left, to the right, of the 0, half of the period to the left. And what I try to remember about cotangent is it has an asymptote at 0 and it goes up to down. Let's look at what this looks like. 3/2 tangent x plus pi over 2. Tangent has a 0 at 0 and it goes down to up. That's my first information. 3/2 is what I would call my fake amplitude. That's telling me how much up and down I'm going to go from my 0. There's no coefficient of x here, so the period will be pi. And that plus pi over 2 means the same thing that it always has. That is a shift to the left of pi over 2. Let's go ahead and put our shift left pi over 2 in first by putting in our new y-axis. Next, we know that tangent has a 0 at 0. So that's where my first 0 will be. The period is pi. I will have asymptotes on either side of the 0, both half of pi away. Over here, there's pi over 2, and over here, there's pi over 2. Now I will put in the 3/2. Tangent is down to up, so in between my asymptote and my 0, I'm going to have a point down 3/2 and then a point up 3/2. And there she is. Another one. -2 cotangent x minus 3 pi over 4. Cotangent has an asymptote at 0 and goes up to down, but because we have the negative, it's going to flip over and go down to up, but it will still have the asymptote at 0. We didn't turn it into a tangent, we just flipped it upside down. Then our fake amplitude is 2. That's telling me how far up and down I'll go. The x does not have a coefficient, so the period is pi. And we have a minus 3 pi over 4, which means I'm shifting right, 3 pi over 4. The first thing that we will do is put in our shift. Notice we already have a scale here on our graph, and that scale is that each box is pi over 4. Looking right, pi over 4, there is my new y-axis. Cotangent starts with an asymptote, which means that I'll put an asymptote over that new y-axis. And then we have another asymptote pi away, so 4 boxes away. I could have gone left if I wanted to go the other direction. And then my 0 then is directly in between those two. Now I'll put in my fake amplitude. Usually with cotangent, between the first asymptote and the 0, I would go up, but we flipped it, so I am down 2, and then on the other side, up 2. Let's look at another one. -2 tangent 3x. Tangent has a 0 at 0 and goes down to up, but it has a negative, so we have to flip it. It will go up to down. My fake amplitude is 2, and the period is 2 pi over 3. We don't have a scale on this graph. We need to put one there. I say let's let 2 boxes be pi over 3. Therefore, 4 boxes is 2 pi over 3, and we can see what's happening. I'll write that that's 4 boxes. Now, tangent has a 0 at 0, so I can put that on. And then we do half the period on each side. If the period is 4 boxes, then I need 2 boxes on each side. Those are going to be my asymptotes. And then putting in my fake amplitude. Usually for tangent, between the first asymptote and the 0, I would go down 2, but since we had to flip it because of the negative, I'll go up 2. And then I can put in my graph. Last one. 5/2 cotangent 2x. Cotangent starts with an asymptote at 0. We have a fake amplitude of, as I write a 1, of 5/2. And we have a period of pi over 2. So let's look at what we would do here. We need to look at the scale. The period's pi over 2. I would suggest we make 4 boxes pi over 2 so we can see what's happening. We know that cotangent has an asymptote at 0. Oh, I didn't draw my shape. Cotangent is up to down. And then we have another asymptote at the end of the period. Halfway between is 0. Now we're ready to put in our fake amplitude, right? So between the first asymptote and the 0, up 2.5. Between the 0 and the second asymptote, down 2.5. It's really hard for me to draw those when they get really long like that. Now, I'm just now thinking that perhaps I used a 2 pi a second ago. Let's go check. I sure did. Look here. I said that the period was 2 pi over 3, and that is not correct. The period would be pi over 3. If we keep our boxes the way we had here, everything else was okay. If we leave 2 boxes as pi over 3, just refreshing my memory here of what was going on, tangent still starts at 0, and it still has an asymptote half of the period on either side. But if the period is pi over 3, which is 2 boxes, I'm only going to have 1 box. Oh, that's terrible. 1 box on each side. It does not want to do these asymptotes for me at all. What a mess. Okay. Now to put in our fake amplitude. So we will have on between the first asymptote and the 0, it will be up 2, and then over here is down 2. Because we made our scale so thin there, that's a really thin guy. So be sure you don't make the mistake I did and revert back to 2 pi, that it's always pi over 3 for tangent and cotangent. Last thing, I kind of wanted to sum up really quickly. So for tangent, we start with our 0, right? And then you put your asymptotes on either side, and that's half of the period, each of those. And then you use your fake amplitude to decide up or, how many up or down you go. And tangent usually goes down to up like a cubic. For cotangent, you start with the asymptote and then put in the other asymptote, the period away, then your 0, then put in your fake amplitude, and cotangent usually goes up to down like a negative cubic. All right, I hope you're ready. Hope that was helpful.